I mean, first and foremost, rare earths are in everything. And we've seen that in the last couple of weeks as companies have not been able to secure the licenses they need. We have seen disruptions to manufacturing. We've seen it most visibly from the automotive sector. For example, Ford actually paused the manufacturing of its Explorer in Chicago because it didn't have these rare earths. But we have to remember they're in defense technologies, they're in cancer treatment, they're in MRI scanners, they're in just about everything electronic. So what we have is both this huge reliance, and really there's no significant processing capabilities that exist operational today, which means that we are wholly dependent on China for something that we need a lot of.
Gracelin, Carol and I last Thursday here at the Bloomberg Technology Conference in San Francisco spoke to RJ Scaringe, the CEO of Rivian, the EV maker, and we asked him specifically about rare earths. And partly what he said, and he's been clear that he is working to lobby the Trump administration. His folks are communicating with them about the importance of rare earths, but he also told us, hey, necessity is essentially the mother of invention, and I'm confident that we're going to be able to do some of this stuff, at least in the near future, without rare earths. Do you think that's the case? Are we going to be able, from a technological standpoint, not to have to rely on rare earths for some of these things?
We are going to reduce our reliance. I mean, never underestimate the power of American innovation. We created a vaccine for a virus that we didn't know anything about a year and a half prior to that. So we will absolutely see, I think, a reduction in our reliance on them, number one, in terms of how much we need them. We're starting to create engines without them. However, that is a process. The second thing we're going to start to see is more capabilities come online outside of China. We saw, for example, that Linus is now starting to produce small scale at its facility in Malaysia. The US is kind of trying to warp speed our own facilities in California and Texas. So innovation is going to be a huge part of reducing our reliance and increasing our capabilities.
All right, but how quickly does all that happen? Because I think the other thing we followed up with him, RJ Scaringe, is that none of this is going to happen overnight, right? So how long does it take to kind of make the switch? And then in the meantime, how much are we still reliant on China, or how long will we probably be reliant on China?
I mean, we're going to be relying on China at some level, in my opinion. I know opinions vary on this for probably a few years in terms of being able to meet all of our capabilities. We have to remember this isn't just a problem of capital. In December 2023, China actually banned the export of processing technologies. And there were parts of the supply chain we actually realized we didn't even have the technical know-how in terms of how to do those midstream. So one is building the technical know-how, and that takes a bit of time. It's expensive. So realistically, even if we start to be able to get offtake by the end of the year through domestic capabilities and potentially through non-Chinese foreign sources, before we are comfortably reliant on non-Chinese capabilities for probably a few years.
Gracelin, how much of this is an environmental story? To what extent is the processing of rare earths something that's done in China because other countries didn't want to deal with the environmental consequences of this?
The environment is no doubt one of the challenges that has limited other countries from developing the capabilities. You know, we use the term NIMBY, not in my backyard, because sometimes we don't want these things in our backyard, and we're very happy for them to be done far away. So that was certainly one component. The second thing I want to add to the environment component is generally the United States has deprioritized mining over the better part of several decades. Between the 1950s and the 1990s, the U.S. was actually the top rare earth producer in the world. We were the top uranium producer in the world. We had a Bureau of Mines that was responsible in government for coordinating all of our mining activities. We closed that in 1996. We ceded a lot of our advantages to China and Russia during this time, and that's how they really created a dominant position where the U.S. once was. So the environmental challenges certainly slow down permitting and some of these other dimensions of mining, but we also have to remember there was a broader government deprioritization of the agenda, which is how we found ourselves where we are today.
Well, that's what I was going to ask you. Was it because the government wasn't prioritizing? Was it because companies, you know, really concerned about the bottom line and profitability and making money that they said China can do it more cheaply and more easily for us? Is it because we didn't have the labor pool? Why was it that the U.S. went from being a leader to basically, you know, now it's China's the leader when it comes to rare earth minerals? What would you pin it on?
So if this was a multiple choice exam, all of the above, I hope, would be one option. But there's a few things, right? So when the government deprioritizes something, it creates a negative signal. As a result of government deprioritizing it and a lot of this moving offshore to China, Russia, Australia over time, then mine engineering programs have less, less need to produce mine engineers and other skilled labor for mining operations. So we have a huge workforce shortage here in the United States. Along with that, again, it is much cheaper to do it in China, where there are low environmental standards, where labor is much cheaper. If you go to a mine in Montana, you're not going to have a worker making under $120,000.
Right.
We don't
Right.
have to pay a worker in China that same amount. So basically,
Got
the
it.
overall production costs fell too.